Now let's look at a custom installation. We'll log in. In fact, we can just Alt F1 to go to the first console. As you saw, as we exited, there are a number of consoles, Alt F1 through 3, 4, 5, and it's indexed at 0, so at Alt F8 you're really at 7. So we have 0 through 7, or 8 virtual consoles. So let's go to the first virtual console, log in as root, and by the way, let's just show you briefly where this information is referenced. And in ETC there's a file called TTYs for teletype terminals, which spells out the various TTYs that are defined. So TTYs 1 through 8, which are indexed at 0 through 7, which are referenced in the appropriate consoles. And then if you have a graphical environment such as GDM installed, then it'll be on the final one, 8. Now notice the reference down here, TTY U0, if you're using dial-up, for example, modems, 9600 baud or otherwise. But these are your TTYs, 0 through 8, and on 8, which is really accessible via Alt F9, you'll have your X session. So TTYs 0 through 8. We're able to access 0 through 7 since we currently do not have X defined. So those are the terminals that get TTY or Getty is running on. You can always tell the TTY that you're currently logged into by simply running TTY, just as is the case with Linux or Solaris or otherwise. So we're currently on TTY v0 or Virtual Console 0, which is the first one that's mapped and is connected to the Getty process, which also means if you execute PSAUX and grep, for example, Getty or get TTY, you'll see those instances that are bound to the various teletype terminals. So here are the distinct instances of those items. So this is 3, 6, 7 of those items that are currently apparently bound to the different instances. So with that said, how do we get a custom installation going? Well, what is custom relative to what we currently have installed? Let's DFH. DF shows us the layout of the partitions. Sans swap. So here we see the various slices. Slices A, sans B, and C, of course. D, E, and F for the various important mount points, user, var, temp, root. So we need to think that we will need some of these partitions. We have an 8 gig disk and we'll want to emulate a similar configuration. So we'll be configuring perhaps root, var, user, etc. Notice user is 4.4 gigs, of which the majority of it is used. So this is where we need to be sensitive with respect to how much space we allocate to user. So however we allocate home, we need to ensure that user has enough space. Otherwise, we need to ensure that the root file system has enough space to take into account the user file system. Why does this take so much space? It's simply because of the ports. We installed all of the ports. These are the ports. So for example, if you wanted the bash shell, it would be in the user shells. Let's go to shells and bash subdirectory. So from this directory, we could compile bash, make it available. If you do a which bash in its ports form, you don't see it. If you do a where is bash, we see that it's in user ports shell. So it's currently not available. It has to be compiled via the make process to make it available. So it's because we have all of these ports on the system. You can do a du, for example, standard command, to go through and check everything out. Let's take a look at where we are. Du 1 level up. And that's just a bash directory, which is why it's so small. And this will come through the tree and return the full stream that we've seen. So rather than wait for this, let's kill it because it'll take a while to account for the myriad files. And we'd like to perform a custom installation which will allow us to become more intimate with using fdisk to lay out our hard drive. So again, df-h gives us a sense that root, user, var, and temp have been separated. Ignore devfs. That's a dynamic in-memory file system used for detecting changing hardware on the system. So it's an automatic means of provisioning nodes in /dev for the different physical devices that are connected to the system, USB, SCSI, SATA, and so on. So to get a new installation going, we need to ensure that the system boots from the ISO image, which is currently the default. It's been reset since we have finished the last session. So all that's needed for us to do is to reboot. Now there are a number of ways in which you can reboot. For example, you can initiate an init 6, which tells the init process, which is the first Unix process, to reboot, or you can type reboot, which is simply an alias to init6. Services are being closed, the disks are being synced, only one in this case. Rebooting from the ISO image, which is akin to booting from a CD-ROM or DVD. We'll press space to interrupt the process, and then boot FreeBSD, the default option. We'll look at the other options later on, including single user mode, of course. So let's boot the installer. Simply selecting the number does the trick. And momentarily we'll be placed under the auspices of sysinstall. So here we are, we'll select the defaults. Now again, standard, express, custom. Since we've done standard, we'll skip express, which is just a quick installation for experts. It omits a lot of settings, but custom allows us to indicate every or influence every part of the installation. Now before we proceed, there's another option we didn't look at, and that is options. This allows us to set options governing the installation, such as NFS options, whether or not DHCP is to be used, the FTP username in the event that we are installing via FTP, the release that's to be installed, where the root directory is to be located, the default editor, and a number of other options. So from within this menu, QQuits returns us to the main menu where we'll select Custom. Now in Custom, notice we can interact with options, which we've just mentioned, partitions, which of course will show us the partitioning or the current layout of the disk and allow us to partition it. Now we can delete the slices that are here. Since there's no important information, we'll just D to delete. And notice the last one registered that it was unused. That was the legacy slice. So here's the entire disk, sector 0 through the end, 216, 16,777,216. To create slices, we can define the individual slices or just instruct the operating system to use the entire disk. Then we'll save the changes. But remember, that does not define partitions. That's just the slice that's actually defined. Let's go ahead and install the FreeBSD boot manager. So we have our slice information defined. And again, it's independent of the individual mount points, which we handle through the label section. Let's just go back to show you that. So partitions, which are slices that are allocated at this stage, are referenced as partitions. We lay out a slice, one or more, which is a FreeBSD type 165. We select how the system is to be booted, whether standard, none, or boot manager. Standard, again, does not prompt us with options in the event that you'd like your system to not be interrupted upon boot. But the way we provision the mount points is via the label option, or number 4. So we need some mount points. Notice above, the default disk is DA0, the first SCSI or SATA disk, and we are working with the first available or usable slice. Now, we'd like to create partitions. Notice we still have the option to define the suggested layout using auto, which is A, which sets up temp, var, user, swap, and root. But what if this isn't going to suit our needs? What if it is not apropos for our configuration? Then of course we can omit these changes and create our own layout. So using U, we'll undo our settings and return us back to the slice or partitioning screen. So let's save the changes. Boot manager, it's a loop. We just keep going through it. And here are the mount points that have not been deleted. We can delete each one of these. Lowercase or uppercase will do. So now we have no partitions or mount points defined within the main slice. C will create. And then we need to determine how big or how many blocks the partition for this particular one, let's say root, is to be. So should it be a gig, 2 gigs? We know an entire 8 gigs will be the full 16 million blocks. And if you divide it by 512, that's where you get your 8 gigs from. So if we divide, let's say, 2 million of those blocks, we should be roughly in the 1 gig space to have our root file system. So something of the order of 2 million will give us this partition. Now, should it be a file system or swap partition? Well, the first one is A, so it will be a normal file system UFS. And notice that's just under a gigabyte for the root file system. UFS2, it'll be formatted. We still have a number of blocks to go. So notice as you make changes, you see above the number of blocks remaining. So just divide it roughly by half to get a sense. You can be more precise by dividing by 512 on a separate calculator. So let's go ahead and create another partition. Now B is normally reserved for the swap partition. And we would like our swap partition to be twice memory. The memory for this system is 512 megs. So let's also make it about the same, which will be about 2 million blocks. And this will be a swap partition, which is type B. So AB, that's taken care of. Now we have swap that's roughly twice random access memory, which suits our configuration for whatever purpose, perhaps for a specific application. That leaves us with about 12.7 million blocks. You divide it by half, that gives you roughly 6.3 or so gigs to cut up for the other applications or other points. Now we know user and var and home are of importance. So if we have 6 gigs, perhaps we should split them 2 each. User, var, home. Temp can always make use of the root file system. Or perhaps we give var 1 gig, temp 1 gig, and user and home 2 gigs each. So let's go ahead and create a new partition. So this will be the next one. We'll say this is for perhaps user. So let's make user 2 gigs. We'll make it 4 million blocks. That's roughly. That'll be a file system. And we're going to make it /user. And that occupies position D. And that's just under 2 gigabytes, leaving us 870 or 8.7, almost 8.8 million blocks free, which is about 4 gigs. So we said we have temp, var, and home left. So we want var and home to be 2 and 1 gigs respectively, and temp to be 1 gig. So let's go ahead and create a new one. And let's make this home. And home will make it 2 gigs, so that's going to be roughly 4 million blocks as well. Normal file system, Unix file system version 2, and this will be for home. That's 1953 megabytes. Create again. Let's lay out var, and that's going to be a gig, so that'll be about 2 million. And that's going to be /var. And then we also need one for temp, so as long as user is taken care of. Now, if you recall, when we installed the full ports, we needed roughly 4 gigabytes, so that could be a problem. So let's think this through. Let's delete these. User needs to be bigger because it's not going to cut it at this particular stage. Well, what does that mean? Do we need to delete and then recreate? Well, let's go ahead. That's the easiest way. We'll delete and recreate. So to get it the 4.4 gigs or so, we're going to need roughly 8 million blocks, which is a lot of storage. So let's go ahead and create this new partition. You need to be on the master partition scale. So 8 million blocks will put us roughly in the ballpark of where we need to be, leaving very little space. And let's make this /user, because again, ports are installed beneath user. That's 3906 megabytes, and that leaves us just about 2 gigabytes available for the other partitions. Now at this stage we can create the individual ones with just enough space. For example, let's create a new one, and we have about 2 point something gigs. So let's make home, since this is just a test configuration, 1 gigabyte will do, so that'll be about 2 million blocks. And that'll be /home. And again, any key partition that you don't create at this stage will be lumped under the root file system, so that's something to be wary of. So 2.7 million blocks leaves us with roughly 1.3 gigs left for temp as well as var, which we can split up. Let's make temp 500 megs, which will be about 1 million blocks. So we'll create, and this will be for /temp, and that leaves us roughly 850 megs or so left for var. So let's use the remainder of the space for a file system named var. So let's look at this. We have 865 megs for var for changing data, just about 500 megs for temp. Home is about a gig. User, the most important, is just about 4 gigs. Swap, double random access memory, and root is just under a gig. So that should suffice for a custom installation. We can always allocate, since this is a virtual instance, storage on the fly as necessary and then move things around. For example, var can be offloaded, temp can be reconfigured, and even user can be reconfigured. It's suggested, however, that you don't reconfigure directories that change often or contain key links in multi-user mode. So if you wanted to move, let's say, user around, the idea is to disable multi-user access via single-user mode and then make your changes. And we can always provision additional swap storage on the fly as necessary. The root file system will not change, however. To commit these changes at this point, we queue to finish. All the mount points are in place. Now, the distributions that are of interest to us is the next step. It's all spelled out for us. Now, would we like to have all system sources and binaries? This will take a while, or just developer, kernel, user, etc. Depends on what applications are of interest to us. Let's go ahead and select all. I'll tell it to install all of the ports, which will take a while, so we'll time elapse it, and then tab down to OK. The installation media will be CD/DVD, or optionally some network-based source. And at this stage, we're ready to commit the changes to the hard disk, meaning the reallocation of our storage slices and contain partitions and mount points, which will be written to /etcfs tab. So again, the idea is to have this sort of configuration in mind, meaning you're partitioning well ahead of time. Or, of course, allocate much more storage so that you have much more latitude when things are up and running. So now, things are being extracted. As mentioned, when FreeBSD is installed, there are a couple consoles available via Alt F1, which is the current console, and Alt F2, which enumerates verbatim what's being copied and what's taking place on the system in terms of partitioning, as well as files that are being copied. And then this will go through the process that we went through earlier. And Alt F2 will just show us that. So just to quickly reflect on what we've done, we decided to go with a custom installation which presented us with a series of steps akin to a standard or express installation, but gave us more latitude over the installation altogether. With a standard installation, you can make changes, but it's just quicker. Standard and Express are simply quicker because things are pre-formatted, ready to go. With custom, each step of the way, you need to tell the system what's of interest to you with respect to how the disks are to be laid out, the distributions that you'd like to select with respect to ports, as well as other options such as whether or not to use NFS, whether or not you authenticate with FTP as a user named FTP, or otherwise. So these items will be extracted from the ISO image. Now there's an alternate ISO image per platform available for FreeBSD, which is a smaller footprint which allows us to install FreeBSD across the wire. It's about 100 and something megs for the AMD 64 Intel x86_64 platform. That ISO image, if you're using a virtual instance onto VMware or otherwise, will boot and then prompt for network access to the remainder of the code, at which point you can indicate an internal server or a server on the internet via FTP or HTTP. So again, that ISO image is just over 100 megabytes. The ISO image that we're currently using is about 700 megabytes, just under 670 something megabytes, and it contains the ported applications which will be populated on the user partition. Now we've made things tight with our /user mount point, which can cause problems later on. To rectify those problems, as we've mentioned, single user mode can be used to extend things or to reallocate things. So if at some point we use our instance in VMware to access more storage or provision more storage to the instance, we can then return to single user mode and offload, presuming, of course, we've done a backup of the partitions that we'd like to reorganize, but we can offload things and reallocate the partition and then end up with more storage. Partitioning is perhaps the most important component of system installation because it dictates your availability and reliability for that matter. If a partition fills and it's a critical one, it could bring the system down. So long as it's not the root partition, your system should continue to run. However, if, let's say, for example, there are updated ports that you've downloaded which push the limit of the /user mount point, it could cause trouble. Not necessarily bringing the system down, but perhaps slow ups in system responsiveness with respect to running applications that come from /user. Let's see what's happening on Alt F2. So it's currently doing SendMail, OpenPAM, BSM, etc. So a number of things are being copied, or extracted, that is. Again, the ISO image contains tar, bzip files, which contain the base operating system as well as many of the other key items that are part of the FreeBSD release. Also, sysinstall provides a minimal interface for interacting with the documentation that's included with the ISO image for your platform of choice. In the root directory of the ISO image, you'll find, which you may burn to a CD, DVD, or otherwise, you'll find a number of documents, including the errata file, which mentions any problems associated with the current release, a release document, which includes notes surrounding the release, which includes bug fixes, caveats, features, etc., as well as a number of other items. A hardware file comes to mind, which tells you the hardware compatibility of the release of FreeBSD, and that will give you a sense as to whether or not it'll run on your particular platform with the hardware that you have configured. Again, FreeBSD can be installed with a minimal of resources. As little as a gig of storage will do, even less. 128 megs of RAM is more than sufficient. A swap of 2 to 3 times RAM is more than sufficient. But ideally, with storage being cheap nowadays, you'll want to provision much, much more. It's also important to note that X11 is not configured by default. Unlike Linux, we're not installing FreeBSD via a GUI. This is entirely text-based. That means the GUI is configured entirely after. We use the package add command after the system's up and running in text mode, which FreeBSD is famous for, which is why it's so reliable, to install Xorg and the various desktop environments such as GNOME and KDE. At that point, we'll have a full GUI environment and can interact with our FreeBSD system from a GUI perspective. But it's important to note that if you're deploying FreeBSD as a server, then you should really consider whether or not it is worth installing a GUI, which tends to bog the system down. Unless you intend to interact with the system on a regular basis, then it is something that you should consider to avoid wherever possible. So this seems to have been installed successfully. Let's take a look with the Alt F2, and so far so good. So this has been completed, and we can do post-installation tasks as we've done already. Let's go ahead and look into the time zone, and it is set to UTC. So we'll set this to Eastern Standard Time for the United States. Let's just page down to that area and select Eastern Time, and that's reasonable. Insofar as networking, let's just go ahead and configure our interface. And as we've done before, the IP address will be .40. IPv6 will be auto-configured. And all looks the same so far, but again, custom gives us more flexibility. But you can turn a standard into a quasi-custom installation as well. Let's tell it not to use DHCP. So the host's name is UnixCBT1, UnixCBT internal, which will be transposed to the domain field. 75.1 is the gateway. 101 is the name server, and the address is 7540. No extra options are necessary. Let's bring the interface up. And then, once that's in place, we will tab over to OK. There are other items that can be configured, such as NTP, for example, but we'll leave that for standard configurations after. And those are kernel loadable modules in the event that you have hardware that is not supported by default by the default kernel. Let's go ahead and set the root password, which we didn't do in this format because this is a custom installation. And that looks good. You can add a user here. So let's add a user Unix CBT as we've done before, indexed at 1001. Setting the user's name as we've done before with the default shell. Because the ports package is installed, we can provision bash at a later point. And let's just go ahead and cancel, exit one level up. That user has been configured. So these are the areas that are of interest. Configure system TTYs. The defaults work for us, so we'll leave them for now. So at this stage, we're pretty much set. Let's go ahead and exit this menu. The system has been installed. As mentioned about the documentation, if you go to doc, you'll see the documents that we've referenced. The README file, the errata, and the hardware, copyright message, etc. Now let's go one level up, and we're ready to exit this installation. And then the system will reboot. Now again, we need to ensure that the system will not boot from the ISO image. With VMware, you simply tell the instance not to boot from the ISO image by selecting the settings of the particular instance. And then we'll go ahead and tell it to reboot. We can expedite by pressing enter, but we'll let it follow its course. There's the main menu. Let's boot the default by pressing 1. Notice the dates above that date back to the 80s, since BSD comes from 4.4. FreeBSD comes from 4.4 BSD. And momentarily we'll see the SSH key generation and we'll be up and running. And of course DFH, there's our new layout. So temp, user, and there is our current configuration. And notice that we're using quite a bit of that /user partition. So that's definitely an issue. That's largely because of the ports. It's actually using more. So that's a creative cross-reference to the /root partition. So we're up and running again, and this is back in business. But again, user should possibly have more. So what we'll do next is allocate even more storage so we have some more breathing room for all of these partitions and include some more mount points such as opt as an example.